Welcome to our lesson on finding the distance from a point to a line. This concept is fundamental in coordinate geometry and has many practical applications in fields like physics, computer graphics, and robotics. Today, we'll learn the formula for calculating this distance and understand why it works through visual examples. Let's start by understanding the problem visually. Suppose we have a line with the equation 3x plus 4, y minus 10 equals 0 in the coordinate plane. And we want to find the distance from the point with coordinates 2, 1 to this line. Before we calculate the distance, let's understand the formula. The shortest distance from a point to a line is always along the perpendicular from the point to the line. The formula for the distance from a point with coordinates x naught, y naught to a line with equation ax plus by plus c equals 0 is given by the absolute value of ax naught plus by naught plus c divided by the square root of a squared plus b squared. Let's identify the components in our problem. From our line equation 3x plus 4, y minus 10 equals 0, we can see that a equals 3, b equals 4, and c equals negative 10. Now, let's calculate the distance. We substitute our values into the formula. D equals the absolute value of 3 times 2 plus 4 times 2 plus negative 10, divided by the square root of 3 squared plus 4 squared. This simplifies to the absolute value of 6 plus 8 minus 10, divided by the square root of 9 plus 16, which gives us the absolute value of 4 divided by 5, which equals 4/5 or 0.8. So the distance from the point 2, 2 to the line 3x plus 4, y minus 10 equals 0 is 4/5 or 0.8 units. Let's understand the geometry behind this formula. The numerator of our formula, ax naught plus by naught plus c, represents how far the point is from satisfying the line equation. If this value is 0, the point lies on the line. The denominator, square root of a squared plus b squared, normalizes this value based on the slope of the line. It's actually the magnitude of the normal vector of the line. Visually, we can think of this as projecting the vector from any point on the line to our target point onto the normal vector of the line. Let's try another example to solidify our understanding. Consider a line with equation y equals negative x plus 3 and a point at 4, 5. First, we need to convert the line equation to the standard form ax plus by plus c equals 0. So, y equals negative x plus 3 becomes x plus y minus 3 equals 0. Now we can identify our variables. A equals 1, b equals 1, c equals negative 3, x naught equals 4, and y naught equals 5. Substituting into our formula, we get d equals the absolute value of 1 times 4 plus 1 times 5 plus negative 3, divided by the square root of 1 squared plus 1 squared. This simplifies to the absolute value of 4 plus 5 minus 3, divided by the square root of 2, which gives us the absolute value of 6 divided by the square root of 2, or 6 divided by root 2, which simplifies to 6 divided by root 2 times root 2 over root 2, which equals 6 root 2 over 2, or approximately 4.24 units. In conclusion, the formula for finding the distance from a point to a line is a powerful tool in coordinate geometry. Remember, for a line ax plus by plus c equals 0 and a point with coordinates x naught, y naught, the distance d equals the absolute value of ax naught plus by naught plus c divided by the square root of a squared plus b squared. To use this formula, 1. Ensure your line equation is in standard form. Ax plus by plus c equals 0. 2. Identify the values for a, b, and c from your line equation. 3. Substitute these values along with your point coordinates into the formula. 4. Simplify to find the shortest distance. This formula works because it gives us the perpendicular distance, which is always the shortest path from a point to a line. Thank you for watching, and I hope this explanation helps you understand how to find the distance from a point to a line.